Hi, everybody. Welcome to Read Science. I'm Joanne Manaster here as your host, along with Jeff Schomeyer, my co-host. There you are. And today we welcome back Mario Livio, who has been on, he was on an early broadcast. Jeff, do you have the stats on that one?
I forget which one it was, but it was sometime, and I think about number 5 or number 4.
Yeah, you were one of our first guests, so we're glad you decided to come back. We didn't scare you away.
Good. Well, I'm happy to be back.
Thank you, Mario. So Dr. Mario Livio is an internationally renowned astrophysicist, a best-selling author, and a popular speaker. And I follow him on Twitter, so I pay attention to what he has to say all the time. He's a fellow of the American Association of the Advancement of Science, and he has published many, many scientific papers. The number here is 400. That's a very busy person. Scientific papers on topics ranging from dark energy and cosmology to black holes and extrasolar planets, which is the hot topic, right? Why Dr. Livio is why Dr. Livio is here is because he writes popular science books, including The Golden Ratio and Is God a Mathematician? That's, I think, where I first heard of you. And then your book, Brilliant Blunders, is why you visited us last time. From Darwin to Einstein, Colossal Mistakes by Great Scientists That Change Our Understanding of Life and the Universe. So we talked about scientists being human, right?
That's right.
And this was a great book. It was one of the, Washington Post said it was one of the best books of the year, and it was a great book. I loved it. So, but today we are talking about why, what makes us curious. And yeah, I just finished it last night. So I really enjoyed it, actually. So Dr. Livio, we are glad to have you here. Thank you for joining us again.
My pleasure.
I think this book, it just struck me while you were saying that. This book is self-referential in a way, isn't it? Because the reason you write these books is because you're curious about things, and this is how you go about satisfying some of your curiosity, I'm thinking. And so here you are being curious about curiosity, which is quite a curiosity itself. And I had trouble deciding just where I wanted to start things today, but I have some quotations from in here that I want to get to, and I think we're just going to have to start by talking a bit about what curiosity is, because that's about what they are. And early on, as I think a straw man, you introduce us to one of the early theories, I'm thinking, of what curiosity is, known as the knowledge gap theory. And maybe we can start there and say a few things about curiosity so that we can talk about it more easily.
Okay, so I thought you would start with the fact that there are different types of curiosity.
Well, that comes into it, certainly, yes.
Right. So let me say a few words maybe about that, and then we'll get to the information gap theory. So I discovered, while doing the research for this book and talking to many psychologists, neuroscientists, and so on their experiments, visiting some labs, I discovered that curiosity is really not one thing. It is a family of mechanisms. And in particular, there was this psychologist, Daniel Berline, was British-Canadian, who tried to chart curiosity on a plane with 2 axes, and he had these 4 different types of curiosity, and I think it's important to mention that because they then make more sense when we talk about curiosity in general. So one axis ran from perceptual curiosity to epistemic curiosity. Now, what are these? Perceptual curiosity is the curiosity we feel when we see something that's surprising or puzzling, or something that doesn't agree with things we thought we know, or something that's ambiguous. We cannot tell whether it's that or that. That's perceptual curiosity, and it's typically associated with an unpleasant feeling, a bit like an itch you need to scratch. Then there is epistemic curiosity. Epistemic curiosity is this true love of knowledge, is what drives people to do basic scientific research. What drives, you know, the most elaborate artworks and things like that, music. This is really, you know, this thing which philosopher Thomas Hobbes called the lust of the mind. That's epistemic curiosity. Then on the other axis, Berline had these two other curiosities, one which he called diversive curiosity, which is things we do basically to ward off boredom. You know, this is what, when you see somebody that's continuously checking for text messages on their phone, I mean, that's diversive curiosity, you know, what arrived now, you know, things like that. And finally, there is the very simple specific curiosity, which is the curiosity when we miss a very particular piece of information, which we need to know, like, you know, who wrote The Old Man in the Sea? Or you know, what was the name of the actor in the movie we saw last week? So where a small piece of information, you know, gives you what you need. Now, coming back to your question about the information gap. So this was originally suggested as a comprehensive model for curiosity. We need to remember this, because at the end, it turns out it probably isn't a comprehensive model. It just is good for some types of curiosity. And the information gap basically said that if you look at our curiosity as a function of our knowledge, you know, imagine that on the vertical plot you have curiosity, and on the horizontal plot you have knowledge, then you get something like an inverted U-shaped curve, which means when you know very, very little, and I mean really little, you're not very curious about it, because you don't even know what to be curious about. You don't know anything about the subject. When you know a lot about the subject, you're also not very curious, because you feel that maybe you know almost everything by now. When do you get really curious? And when are you at the peak of this inverted U shape? That's when you already know something about the subject, but you know or feel that there is much more to be known. That's when you are really curious.
Well, you talked earlier about the information gap. I think because, I don't know, maybe we had more context, and you also talked about, you use Feynman and Leonardo as sort of test models for some of these ideas of a really curious person. It didn't feel very satisfactory to me, even from the beginning. And I think maybe I could tell that you were going to take that apart and replace it with some ideas. And the first time that I really felt like you said something that was undeniably true was around the time when you told this story about Feynman as a child with his father.
Yes.
And this involved, was this one a bird?
Yes, birds.
Could you relate that? And then I want to read what you said about that.
Yeah, so Feynman tells this story that how with his father, you know, they were walking and they saw this bird that was pecking or preening its feathers, you know, and his father asked him, why do you think the bird does this, you know, pecking its feathers? And Feynman said, well, maybe the feathers get messed up when the bird flies, and therefore the bird needs to arrange them when it lands. And then his father said, well, okay, let's test that to see if that is true or not. If that is true, you would expect that birds that just landed on the ground would be doing that much more than birds that have been already on the ground for a long time. And then they looked and they saw that there was no difference between birds that just landed or birds that were on the ground for a... So then they decided that that's not the correct explanation. And his father gave him another explanation, which actually was not true also in the details of it. But the point was really to make the boy, you know, question and test his ideas and things like that. It was not to give a specific, very detailed, clear answer to the question.
And now that's sort of, you described that when you finished that as saying that his father created in Feynman's mind an information gap that appeared to be surmountable. But I think we'd pretty much left the information gap behind by that point. And sometime rather earlier on, but it resonated when I got to this part. You wrote, "We are not particularly interested in subjects about which we know almost everything or practically nothing."
That's right.
That's the sweet spot on this curve, right? When we know enough to think maybe we can know more.
That's right.
And that seemed almost, I don't know, do you agree? That seemed almost as close as we could get to saying, that's curiosity there.
Right. So that's curiosity, I think. It particularly, I think, describes well perceptual curiosity, and things like this. I don't think it is still associated, that situation is still associated with a somewhat unpleasant state, with an aversive state, because this feeling that there are things we don't know that there yet, and so on, bothers us at some level.
That's a good starting point for exploration, though, in a lot of science labs.
That's right.
Or learning hobbies and things.
That's right. But then you also get into the situation where you regard the exploration and the search for more information as a pleasurable state. That's where epistemic curiosity sets in. That's where an epistemic curiosity is associated with an anticipation of reward. So we see this knowledge as a reward. It's, we feel it a little bit like the same when somebody offers us a piece of chocolate, or when, we sit in a theater in a play we wanted to see and we're just about, the curtain is about to go up.
But the pleasure from that sort of curiosity then is the thing that says the information gap theory might help us understand some things, but it's not the whole story by any means.
That's right. Exactly.
And then sum that up, there's that whole science thing that we'll come back to several times, but you quoted Jacqueline Gottlieb by saying, "My greatest joy is when I learn something new." And so
that's right.
That's the payoff.
That's right. And that's right. And that was also repeated by Fabiola Gianotti, who is the director of CERN, the European Center for Nuclear Research, where the Large Hadron Collider is. She said almost verbatim the same words. And Jacqueline Gottlieb, by the way, I should say, was extremely helpful to me in writing this book, because she's a researcher at Columbia University that really, all her research focuses on curiosity.
Right. So actually, I found this interesting. I always find it interesting. So to be such a good writer that you're willing to step outside the bounds of your normal, research.
Comfort zone.
Your comfort zone. So how was that? So here's me as a biologist. I also learned from the book that your wife is a microbiologist, or was. That, so how did this feel talking about fMRI, parts of the brain, the reward centers of the brain, how curiosity actually feels like a reward.
Right. So it was a little bit frightening at first, I must say. The way I did this was in a two-step process, but one of which was much shorter than the other. I mean, I knew that I was an extremely curious person, and I was extremely curious about curiosity, how that works, because this is such an important part of my personal life. And I thought, that of many people's lives, that I wanted to understand this. But I wasn't sure whether, as an astrophysicist, whether I can actually go into all the literature in psychology and neuroscience and understand it. After all, there is all this jargon that people are using, and there are things, there is a lot to learn. So what I did in the first step was I was invited to give a TED talk at TEDx Mid-Atlantic, and I gave them, they allowed me to choose the topic on which I wanted to talk. and I gave them as the topic curiosity. Because I knew that would force me to spend some 6 months or so, looking at the subject to see whether I even have a chance of, getting into it and say something intelligent about this. So, a TED talk is a short talk. It's an 18-minute talk. So I thought, if I cannot even gather enough material about curiosity that I actually understand to put it into that, then there is no point in, you know, trying to explain much further, because it would just take the rest of my life. But I discovered then that, you know, I could get into it, and I learned some of the jargon, you know, and so on. And I interviewed already a number of neuroscientists and talked to them, and I managed to do that. And at that point, I decided, okay, it's worth my while, you know, to do more. And then I spent more than 4 years researching for the book and getting into that.
Did it end up in the usual laboratory science way of did you answer some of your questions finally to your satisfaction, but discover new questions that you don't know
Of course. I mean, I you know, since originally I knew very little about it, I answered many questions, but I discovered how little we actually know about curiosity. I mean, this was actually one of the most surprising things to me. For example, even to discover that, you see, I thought that curiosity is so important. Naively, I thought that almost every neuroscientist, you know, has to work on it at some level. I discovered, no, that's not the case at all. In fact,
I was surprised by that too. That actually surprised me in your book. Where are all those scientists? Yeah.
There are very few who actually really, I mean, you know, some touch it marginal, you know, in their work, but people who concentrate on studying curiosity, both on the psychology side and in the neuroscience side, are actually few and far between.
But you have to have, are they lacking a place to start to find initial questions and as a way in, or are they just leaving it for someone else? It's not close enough to their field. What's kept them away, I wonder?
No, I think, you know, the thing is that in neuroscience in general, and, you know, in understanding things, at the end of the day, curiosity is part of our consciousness. And consciousness is such a broad field. There are so many things there. And plus, there are so many clinical conditions that people are invested in, you know, like you know, solving for Alzheimer's disease, things like that, and so on. And there are so many such topics that even though there are quite a large number of psychologists and neuroscientists compared, let's say, to astrophysicists, they still have so many topics to get into that really not all of them get into this. And in particular, you know, progress is relatively slow and somewhat hard because, you see, for example, I cite 2 experiments, one done by a Dutch neuroscientist, Marieke Jepma, and another one done by a woman named Kang, done with functional MRI. Well, guess what? You know, in each one of these 2 experiments, which are, in my opinion, landmark experiments in the study of curiosity from a neuroscientific perspective, yes, they had 19 subjects in each one of these studies. You know, it's hard to get lots of people and put them into MRI machines and, you know, design all these experiments and so on. You're not going to get very quickly to having 30,000 people in MRI machines, you know, to study their brains when they are curious. So it's hard.
And in a way, the results were not so very satisfying, but served the very useful purpose of being at the top of a branching chain of questions. You see what they do now and you go, oh, this could be done better. This was not a good assumption. Here are some questions we need to look into. And that's really better than getting the right answer, isn't it?
That's right. And indeed, I describe a few follow-up experiments that Gruber and company did, and others, you know, and so on. But it is still, to me, what was very impressive, even in this relatively limited number of neuroscientific results, is that, for example, the fact that perceptual curiosity, psychologists thought, is perceived mainly as an aversive, unpleasant state, while epistemic curiosity as a pleasurable anticipation of reward state, that was actually confirmed, at least to the level that you can confirm things with 19 subjects, from the neuroscientific results, because it turned out that indeed perceptual curiosity activates those parts of our brain which are associated typically with conflict or with hunger, while epistemic curiosity activated the parts of the brain that are associated with anticipation of reward. So now the psychology and the neuroscience seem to come together in identifying, that these appear to be two different mechanisms.
And the functional MRI has had a big vogue for a few years, and we learned some things, and I think mostly we learned a lot of things that we didn't actually learn. And so, you look, you have these very clever psychological tests, and you see what area of the brain lights up, and that leads to things, but that also, I'm working down to quoting David Alexander, that also seems after a while to be a somewhat naive understanding that there's things light up, but other things light up, and there are parts of the brain that take a little longer, that override these parts of the brain, and all of these mechanisms are likely to be operational in various types of curiosity. And so here's the David Alexander quotation in a paper that's talking about these things. You said, "We question the very notion that neurological entities are events that occur at certain locations and times, rather than being comprised of trajectories that extend over locations and times." And I think he's got a truth there, which doesn't deny what we can learn really from the fMRI.
Right. It's even more than that. I mean, at the end of the day, what the fMRI tells you is which part of the brain is activated. Okay, so you know that in this part is activated. Okay, but that still doesn't tell you much about what happens, how does it happen, why does it happen, and so on. It's a step forward, but it's not a huge step forward. And David Alexander had added on top of it another level of uncertainty, which said it's not only that this part gets activated, but in fact, this is all some sort of a traveling wave in your brain, which you cannot really understand unless you understand that not only that it's here, but also where does it travel from here and where does it travel from there and what happens in both space and time.
I'm good with the idea that it's going to take probably quite some time to unravel consciousness.
Of course, it is going to take you quite some time.
For the rest of everyone's lives, I think. Yeah. So actually, let's talk a little bit about wonder versus curiosity, and sort of how this plays into education. I'm sure you can discuss this. So how does learning and curiosity tie together, and what's the difference between wonder and curiosity?
So wonder and curiosity are actually close together, I must say. And at some level, maybe even had we known from the beginning, for example, that, the curiosity that we feel when we are surprised and a curiosity that expresses our love of knowledge are somewhat different in terms of, their neuroscience and so on, maybe we would have given different names to the two things and not called them both curiosity. So, maybe we would have called one wonder and the other, I don't know, anxiety or something, some other names, yes, we might have given. Now, in terms of the connection to learning, then yes, there are many experiments that have shown that curiosity is very closely associated with learning. Namely, we learn things much better when we're curious about them. And also, we learn things much better when, for example, we thought we know the answer, but the answer turns out to be wrong. Then we learn much more from that. So it enhances learning and it enhances memory too. When we're curious about things, we remember them much better. And one finding that I found in particular surprising was that when you're curious, you seem to remember better not just the things you're curious about, but even all kinds of incidental things. There was this experiment where they showed people something and, and asked them to remember that. But in between the things that of the experiment itself, they flashed some random faces. And it turned out that in the situations where people were very curious, they even remember those random faces that had nothing to do with the experiment better. So, I mean, there was a sentence there which say that maybe curiosity is like some sort of a vortex in a fluid, you know, that it sucks in everything around it, whether it's related or not. So that was another interesting thing. So yes, if you make your students or whoever it is more curious, they are likely to remember things better, and they are likely to learn them better.
So let's extend this to science communication.
Yes.
So because some science communicators say, well, you know, our goal is to make people curious so they'll want to know more, right? Which makes sense, and you are probably doing that by writing your books. But then we also have a whole contingency of people who are down at this lower level of the curve. They don't know anything to even be curious. So
right.
I'd like to hear your take on curiosity's role in science communication and getting people to come in and engage in science a little bit more.
Yes. So on one thing you already alluded to, which is, you know, in that inverted U-shaped curve, your goal is to move people from where they don't know anything and therefore are not curious about it, to move them more towards the middle, more towards the peak where they already know something about this and then know that that's interesting, and then they become more curious about this. I mean, so that's one thing, you know, to try to get people into that. Now, how do you do that? You do that, well, partly by asking many questions, partly by doing what Feynman's father did, which was you ask the question, but don't immediately give the answer, but rather tease the person to try to give her or his own answer, and then test whether that answer is correct or not. You know, in the same way with the birds, that, okay, is that the correct explanation of why the birds do that, or is it something else? And finally, there is something that I found very interesting, and it came up in my conversation with Lord Martin Rees, whom I've known for many years, and that is, you should start with the things that people are already curious about. Namely, don't start necessarily with what you want to make them curious about, because maybe at this moment, because they don't know very much, they are not interested in it. And I'll give you an example. The best example is actually with little children. Little children, most little children in the US at least, are fascinated by dinosaurs. Mm-hmm. So you can relatively easily get children curious and interested in dinosaurs, okay? But suppose what you wanted really to teach them is something about why objects accelerate towards the Earth. You know, why a falling object accelerates toward the Earth. You think that every child should know that, okay? About the force of gravity and I don't know what and things like that, yes? Now, the child who doesn't know yet about the force of gravity and things being accelerated towards the Earth may not be interested in that because they don't know anything about that. But they are still fascinated by dinosaurs. So you start with dinosaurs. You talk to them about dinosaurs, everything they are very curious about. And then you find an ingenious way to get to what you wanted. Namely, you say, okay, and you know, the dinosaurs, they became extinct. Mm-hmm. And you know why they became extinct? Because an asteroid hit the Earth some, you know, close to 60 million years ago. And that is what, you know, at the end, it hit it, you know, near the Yucatan Peninsula, and that's how they became extinct. And why does an asteroid accelerate towards the Earth? Because the gravity of the Earth, you know, pulls the asteroid, and, you know, and you continue like this. So you manage to start from something they were already curious about, mm-hmm. and to get them to where you wanted by doing this, instead of starting, oh, you know, all things fall down, and this is, oh, yeah, sure, yeah, I'm not interested.
But to me, the thing that was exemplary about Feynman's father is something that I think adults don't do enough, but children love to do, and that is play. It seemed to me that he was playing a game. They were making up a game to play, and kids that I've known love any sort of game, and they are happy to play a game with any tall person who's willing to do it with them. And you're just making me think, to contrast that with some science popularizers, to be specific, who believe that the way to engage people in science is by being entertaining. But there's a difference, a small maybe, but an important difference between being entertaining and playing a game to excite people's curiosity. And maybe that's the difference. Being entertaining doesn't necessarily get you to those. It doesn't feel to me like it pulls people up that inverted U the same way that Feynman's Father's game will.
Yeah, I think you're right. I'm not saying about that you shouldn't be entertaining. I mean, you know, if your book or whatever it is, you know, bores people stiff, then you know that's so not good. Yes, I mean, it should be entertaining at some level. And there is also a slight danger. You're right about being too entertaining. I remember that many years ago, somebody asked me about how a laser works. Mm-hmm. And I tried to explain to them the concept of coherence, that, you know, things jump from one level to the other all at the same time. And that is what gives this a lot of power. And I gave the example that, you know, if all the Chinese people, you know, jumped at random times, maybe nothing would happen. But that if all of them jumped at the same time, then, you know, this maybe even would cause something to the earth. And the thing was, I was very pleased with this example. But then a few years later, I ran into the same person, and I asked him, do you still remember how a laser works? And he told me, I don't remember almost anything, but I remember it has something to do with the Chinese jumping up and down. Yes. So the metaphor was a little bit too entertaining.
Right, just a little too much spectacle.
So it sort of covered the actual contents that I wanted to convey.
You know, actually, I just was looking at Twitter, and oddly enough, there is an opinion piece at the New York Times that's trending. I have not read it, but I just thought I would say, given that we're talking about curiosity, the title of the piece is called "An Incurious President."
Yeah.
So I don't want to get political or anything.
Yeah,
but what is the danger in not being curious?
I will actually, that I'm happy to tell you, and without mentioning any particular politician. And
you don't have to. But I thought, how interesting, that's trending exactly when we're talking. So
yes. Look, if you look at the biggest problems that humanity is facing today, the biggest problems, you know, things like climate change, things like fighting disease, in particular in entire continents like Africa, you know, and things like that, in finding food resources for all the population on Earth, even things that are somewhat smaller but still important, like cybersecurity, things of that nature. If you look at any one of these problems, you immediately recognize that to not just to solve this problem, but to even just address it requires serious scientific input. Mm-hmm. Each one of the problems I mentioned requires serious scientific input. What that means is that anybody who is at a high-level decision-making position should actually have very easy access to scientific opinion about these things. I mean, they cannot just rely on other politicians around them. They need to have the scientific input. And that's where curiosity comes in. Yes, you need to understand that you need to be curious about these problems and understand what science has to say about them. That is crucial to the biggest problems. I'm not even talking about, you know, there are many even small everyday problems that require scientific input, because science is now all around us. Yes, I mean, we're talking through a computer, you know, across half the continent here. I'm using some device on my ears, you know, all these things, right? And so on. So everything here is, you know, the phone in my pocket here uses both general relativity and special relativity for its GPS system, all these things. So these are on the everyday level, but certainly on the global level, these problems require serious scientific input. So I would hope that every person who is at a level where they need to make big decisions should have the right scientific advice, should have a science advisor. I wrote a piece in Nature in February about Winston Churchill, because I discovered an essay that he wrote in 1939, which was never published in full before. And that essay was called, "Are We Alone in the Universe?" So Churchill of 1939, and you can easily find that piece on, if you Google my name and Churchill, yes? Churchill of 1939 wondered about that question. This is when Europe was on the verge of World War II, okay? So this is how curious he was. And he was also the first prime minister to appoint a permanent science advisor. So that's the type of thing I'm talking about.
But there has to be a willingness to ask questions from these people too.
Of course, of course.
And I don't know that that's prevalent enough, really.
Well, the thing is, the first thing is to recognize that not only that we don't know all the answers, we in fact almost don't know any answer. You know, I mean,
yeah.
This was what marked. Yeah, this is what marked the transition from the Middle Ages to the Renaissance. This recognition that, you know, the Middle Ages were characterized by this notion that was largely, you know, imposed by the church in that particular case, you know, that everything that is worth knowing, we already know. And the transition was, you know, to all these empiricists, you know, like Hume and, you know, others and all these, yes, Locke, and these who said, no, you have to observe, to do experiments. You have to use your senses and find the questions.
Which gets us so handily to your conversation, your discussion about unknown unknowns.
No knowns.
No
knowns. Unknown unknowns.
Yeah. Well,
so famous by Donald Rumsfeld, but he didn't make it up. He just put it in the American consciousness, I think.
Right, but he wasn't discussing curiosity, but without knowing it, he captured this inverted U shape.
Yes,
because you know, when you have unknown unknowns, you're not curious about them, right? You don't, because you don't know what to be curious about. When you have known knowns, you're also not very curious about them because you already know everything. It is those known unknowns that you're curious about, when you know that there are things you don't know.
And you can't really get to that important point of turning on your curiosity by being willing to ask questions unless you believe there are questions that can be asked that are worth asking, which is not going to happen if you think everything that needs to be known is known.
That's right.
Right. Actually, there's the curve that Mario has been talking about all day, which is great. And it's really a helpful diagram to show what we mean. Funny, I did laugh. I giggled. This is a good thing. You're mentioning Kardashians. They came up a couple times in the thing, you know.
Yeah, for a second there, my picture went away. I'm not sure why.
Oh, whoops, you're here.
But it came back now, yes.
Yeah.
No, it is really, it went away again now, for me at least.
But for us, we can see you. So.
Okay, so look, I have absolutely nothing, you know, to say for or against Kardashian. It's just that these are people who appear to attract a lot of attention and curiosity. Okay,
yeah, people are curious. What
is going
on with them, right?
Yeah. So the thing is that I don't see that as a bad thing in the following sense. If people are curious about something, as I said, that's already a good sign. And like I said, the way to try to even channel that for really good purposes is to try to go from that into other things. You see, I mean, let's say you are interested in the Kardashian, but that's also some form of a social phenomenon, right? So you can get from that into interest in a variety of social phenomena, perhaps, maybe economical phenomena. Well, in one particular case, I mean, it even goes into gender issues and things like that. So you can get into various very interesting things, I mean, that most people will agree are interesting, even those who are not originally interested in what happens with the Kardashians. But you can get into these other things from that if you keep your mind open and you understand that one question can lead to another.
That questions leading to another is very good. Now, if Joanne has, I have a new topic, something that I'm very curious about, and that you talked about, and that I want to know, what is the deal? What is the connection between art and science?
Yes.
Art and science.
I know it's big. You can take more than one sentence.
It's a big question, and I would not claim to be an expert, other than the fact that I'm of course a working scientist, but who happens to be an art fanatic. I mean, if you look at most of the books in my house, and I'm talking thousands of books, most of them are about art, because I'm a great art lover. I'm also involved with music. I'm a science advisor to the Baltimore Symphony Orchestra, for example, which is a bit strange, but I am. Now, the way I see it, and it's my personal view, but so I don't know if everybody agrees with that, but the way I see it is something like this. The role of the scientist, or at least the way that scientists regard themselves, is that they try to explain the phenomena around them. They try to explain the world around them. We see phenomena on small and large scale, from the subatomic scale to the cosmic scale, and we try to explain them. But usually by use of mathematics and other tools and so on, we try to find explanations. When I look at artists, the way I see them is that they see the same world around them, but they try more to give their emotional response to this world. Not to necessarily explain the phenomena, but to give you the impression of how they feel about these phenomena. And so in that sense, the art and the science really complement each other, because together they give us a much more complete picture of how we as humans perceive the universe around us.
So they, at some level, you could describe them in very similar ways. They have some similar sorts of goals with very different tools. And so, yes, they go together well. It's worth doing both. And it maybe shouldn't surprise us that scientists are often musical, enjoy art, are fascinated with art.
Well, in particular,
would you say that it's the curiosity to ask the questions, to look for answers or explanations, or more ways to understand and comprehend things?
That's right. And there was a very interesting answer that I got from Brian May, who is the lead guitarist of Queen, but who also holds a PhD in astrophysics. And he basically said that he thinks that his abilities in each one of the fields, the science and the music, enhanced each other. That's how he expressed himself.
There's a famous Feynman quotation that you have one version of it here that keeps turning up in my mind because I'm interested in art and physics. The people who would accuse him of of saying, well, you've taken all the mystery and the awe out of looking at the stars or looking at a flower. And I'm on his side to say, I see the same flower, I react to it, I see the stars, I react as you do, but I know about fusion. Doesn't that enrich my experience?
That's right. It's a bit like getting more actually to the middle of that inverted U shape. You know, that you know already quite a bit, but you feel that there is so much more to it, and so on. So that indeed, that's I feel the same.
And was it Leonardo? There was somebody who was telling us that there are things in anything, there's something to be curious about if you look closely enough.
Both Leonardo and Feynman repeated this almost verbatim, you know, saying everything is interesting if you go into it deeply enough.
Okay, I'm almost done with the art thing because I wrote down a sentence, and sometimes I'm interested in, I can't remember why I made some comment in my notes, and I'm hoping you can explain that we're talking about artists, I think, and I wrote down the question, why do people look at paintings?
So, yes, so I do not exactly know the answer to that, but oddly enough, that psychologist that I mentioned, Daniel Berline, who actually, you know, formulated this model of 4 types of curiosity and so on, actually worked a lot in that area about, you know, what is it that drives our aesthetic feel, you know, why do we look at paintings and things of that nature. And also there was this mathematician, G.D. Birkhoff, who wrote a whole book trying to even quantify beauty. He wrote a mathematical formula for beauty, which was composed of the elements of complexity and order. And, you know, he wanted to say that, you know, if things are too complex, they are not beautiful. If things don't have a certain order to them, you know, they are not beautiful. But if they have too much order, you know, and so on. So all these things. So I don't think we know really the answer to that, but there are some attempts to try to answer that.
But Joanne, does this not make you think of the Gallery of the Infinite?
Sure.
2 weeks ago, Mario, 2 episodes back, we talked to Richard Schwartz, who's a mathematician and who likes to draw cartoons, about several of his books, but the one I particularly liked was called The Gallery of the Infinite, where he's trying to tell us about orders of infinity and transfinite arithmetic and some pretty sticky subjects. And it's a graphic book with rather little text, but important, you know, precise text that gets us through there. But its real strength is in his wacky cartoons. And for example, there was when he's talking about understanding rational numbers as an infinity and or as integers as a countable infinity. He introduced us to the infinite chicken, and this chicken had teeth of all things and braces on the teeth. And Joanne discovered from reading this book with her daughter that his pictures are whimsical, but they have details and things to look at that make particularly the young reader start to look at the picture and do things like count the teeth.
So basically, it makes them curious.
It excites their curiosity.
Exactly.
Those pictures draw people in ways that reinforce exactly what he's talking about.
Right. So this is another example of what I said. Start with the things they are already curious about, and then find ways to lead from that to other things.
Monsters. Joanne can tell us about the monsters.
Yeah, that's a very good book. But actually, Jeff, if you're done with art, I do want to ask about, this is great. You in your book say, I coined the phrase, curiosity is the best remedy for fear. You then discovered, well, maybe you weren't the most original person discovering this, but I think it's great. And then you talked about Irish novelist James Stephens as curiosity's best remedy to fear. Can you explain this to our listeners? I mean, I love this part of the book, and I feel like it's because I feel it's true.
I think this is actually very, very important, and not because I said it, but because I think it's truly important. You see, very often the things we are afraid of, things we're fearful about, we are afraid of them because we don't know enough about them or we don't understand them. If you look throughout history, much of the fear and hatred was caused by ignorance. And this remains true today, as always. And by becoming curious about these things and learning about them and understanding them better, you actually become much less afraid. And, you know, throughout history, we had entire periods, I mean, most notably the Middle Ages, when curiosity was suppressed by a variety of either, you know, oppressive regimes, oppressive ideologies, things of that nature. But that continues to today. I mean, we had periods, of course, of book burning throughout history. We had the degenerate art exhibit by the Nazis in 1937, where they took all the, you know, most of the people we call today modern artists and put them into one exhibit, which they wanted to tell the people that these are enemies of the country and things like that. And, or, you know, ISIS destroying artworks in Palmyra. All of these things, these are all enemies of curiosity, and perhaps most outrageous, of course, the attack by the Taliban on Malala Yousafzai, just because she advocated education for young girls. So these are all elements that try to kill curiosity. And they want to kill curiosity to let you live in fear and in terror, in an atmosphere of terror. And by being curious, that is your best remedy against these things. I mean, that's what you should do. So I really feel very strongly about this phrase. Curiosity is the best remedy for fear. And I was actually, at some level, happy to discover that others thought about this too. Yes, even though I was very proud at first that I say, oh, I came up with this incredible phrase.
And I think even Feynman does, there's a quote that's out there on the internet of him, you know, he's like, well, no, you know, like just about not having religion or God.
Not knowing things.
Than not knowing things, exactly.
Right.
That it's okay, because there's then more to learn, to be curious about.
That's right.
Well, to scientists, not knowing something is an opportunity, usually.
Exactly.
But apparently, some psychologists discussing that would think that people who are comfortable with not knowing things are drawn to science, that it doesn't turn us into that. But do you think we have any tactics we can deploy to help people counter their fear of not knowing things?
Yes, I mean, look, I mean, again, I don't want to get into politics and things, but we do experience something that is very, you know, it's now in our everyday lives. I mean, by saying that, you know, every refugee is a threat to you, you know, I mean, this is just, you know, just playing on ignorance. I mean, you know, most of these people are very poor people escaping from horrendous situations with small children, you know, and so on. Just try to learn something about them and on what they have experienced, and you will be much less afraid of them.
There's an openness that's required, and then you learn something, and that gives you confidence that maybe the unknown is not such a bad thing, that you can get through it.
That's right.
This is something that musicians know too. I think that I've realized recently that stage fright and all of those things, and public speaking is a big fear people have, and the people who do these things have the fear, I think, that seems a natural product, but they couple that with a confidence that they'll find their way to the other side to get through it.
And of course, by learning more about it and doing it more times, that will also reduce their fear.
Yeah.
It's, I mean, so I actually, I enjoyed the whole book, but I found the last part of the book, I could feel your passion for this topic really come through, especially about the fear. And I was interested in the history. You had talked about just the different phases in the human history where, curiosity was quashed.
Right.
And well, we got 5 minutes left. But talking about quashing curiosity, we always talk about children having a natural curiosity, and then at some point, like Carl Sagan was famous for saying, we beat it and whatever, wring it out of them by the time they're teenagers. So, and you did bring this up in the book. What happens to curiosity?
Yeah, I think, what I discovered from looking more at the research, I mean, my impression is that we are a little bit mistaken about what's happening. I mean, we're very used to children asking why all the time. And of course, that's the title of the book too, because children are very, very interested in cause and effect. They learn relatively early on that every effect is done by some cause, and they want to understand the connection there, because that helps them then, make fewer errors in dealing with their environment. So that's why they do all that. And it is true that the things that decline with age somewhat is the ability to be incredibly surprised and the willingness to take risks for novelty. That declines somewhat with age. So if you like, the perceptual and perhaps diversive curiosity, declined somewhat. However, studies show that epistemic curiosity, the love of knowledge, the fact that we are, what was called infovores, that, we try to devour information, that actually stays fairly constant with age. So we shouldn't be too discouraged by the fact that, we are maybe a little bit less able to, take risks for novelty or willing to do that, but it should keep our interest in, learning new things.
I thought that, that was an excellent point in the book, especially, raising 4 kids. Oh, by the way, I loved your daughter's science project for school. Oh, that just delighted me.
A true story, yes.
Yeah, it was very nice. So, she wanted to check how long wearing a lipstick was if one company's claim was true.
Right. So
because you're like, she's interested in lipstick. What?
Yeah. She wanted to see whether the advertising of one company that a particular lipstick is more resistant to kisses is true. So she was really. I thought at first she was interested in lipstick or kissing or whatever, but no, it turned out she was interested in truth in advertising. And we found a way to turn that into a serious scientific experiment. So I was very pleased with that. And it's an excellent example, again, how following their curiosity, gives you much better results than coming and saying, oh, I think you should know about the pendulum and how it works, which bores her to tears,
Exactly.
All those things we didn't get to, just to leave a little bit of curiosity. And your daughter's science experiment, we don't want to give away, but I was surprised by the result. And so I thought that was a very nice experiment. And I can leave this thought with our listeners' minds, that it's like, you'll have to read later on in the book if you want to know about the interesting point that Mario makes, that cooking food may have reduced the time it takes we spend chewing every day, and what that has to do with evolution and why curiosity might well be the product of natural selection. Well, that's all in the book.
So, and actually, with just a minute or so left, Mario, is there anything we forgot to ask you that you wanted to tell us about?
No, I think you covered really quite a bit of it. I mean, my hope truly is to convey how important I think curiosity actually is, because it is important to almost everything we do. From a simple conversation, you don't want to listen to a conversation if you are not somewhat at least curious about it, to reading a book, to seeing a film, to seeing a TV program, to doing advertising, to doing science, of course, to do art. For all of this, curiosity is an absolutely necessary ingredient, and indeed, a necessary ingredient for creativity in general, studies found. So I want everybody to be aware of that.
It's great. Well, Mario, thank you for coming back with us again and for writing your book, Why? What Makes Us Curious. If you guys haven't picked it up, our viewers, you might want to check it out because it's really got lots of good information from historical perspective, psychological, neurological, right? And just observational. I really enjoyed it. Yeah.
There are many ideas that are worth thinking about.
Definitely, definitely. So thank you, Mario. Thank you for
Thank you. Okay, bye.
Okay. Thanks everybody for watching.